Welcome to part 1 of Competency 10 quiz. In this video, we will work with all the properties related to 2 and 3D shapes. Number 1, the dimensions of the bottom of a rectangular lap pool are 10 feet by 6 feet and 4 feet deep. The quart of paint needed to paint the sides and bottom of the pool costs $12.50. The quart of paint will cover 14 square feet. How much will it cost to paint the sides and bottom of the pool? Okay, now let's look at that. We need to calculate the surface area. Okay, now we know there's a bottom, and this is our bottom. Okay, so that will be 10 feet by the 6 feet. But then we know we have two sides, okay, like a front and a back. So two, and let's go with the longest length of the pool. One of those is 10 feet wide, that whole, I mean, not wide, but a length, and then times the 4 feet deep. Okay, that's like a front and a back. Now we have the two ends, okay, the two sides. So we're going to add 2 times. Well, that's going to be the width. The width is 6, and then times that height of 4. Okay, and now that's what we put in our calculator. But remember, this is only getting the surface area. Okay, so we need, in parentheses, 10 times the 6, close your parentheses, plus 2, and in parentheses, 10 times the 4, close, and then plus 2 times those two ends, which is 6 times 4. And yes, you could do some of this in your head, but you're going to be taking a test. A test. Do you really want to risk it? Okay, so let's push enter. And 188 is that surface area. Now, each can of the paint, it will, or these days we say bucket of paint, but it is a quart. This implies that we take this 188 and divide that by 14. So push divide by 14. Okay. Now, that is how many sections we have. Now, I need to ask you. We have 13 sections. Well, we know that that's at least 13 buckets. But then we have this bit left, the decimal. Well, that's part of the section. Well, are we only going to be able to buy enough paint to paint part of a section? No. This implies that we need to round up, and it will be approximately 14 sections. We need to say it's 14 sections because we're going to have to buy the can of paint if we like it or not. If we don't buy 14th can, we're going to have a hunk of the pool that didn't get painted. Okay? All right. So what does this mean? That means we take 14 times the 1250. Okay. And that's $175, which is option C. Now, you would have very much been tempted to use a decimal. And if you did, you would have gotten a very low number. I think the number was, maybe 167 and ish. But when you see that, look at your options, look at the lowest value, and then think about, why is my value a little bit less? Why am I? And then maybe you can think about that. You realize, hey, I have to round up. I can't just buy half or a part of a quart. It doesn't sell like that. Okay, now let's look at number 2. Find the volume of a cylinder whose radius is 3.5 centimeters and height is 12. Okay, so I'm going to clear out what we have. And remember, a cylinder is, let's see, the volume, that is the base of the circle. So that is pi r squared. Okay, remember we're doing volume. It's area of the base times the height. So then I put in 3.5, square it, and then times that height of 12. But what did I put in that caused this not to be the same? I bet I have the right answer. What did I warn you about in other videos? These are in terms of pi. So how do I get which one of these terms works? Well, divide by pi. And there we go. 147, which is option D. That's how you know what to do. Let me get rid of that. Okay. All right, so let's move on to number 3. Find the total surface area of a standard rectangular cone whose radius is 7 inches and slant height is 15 inches. Okay. Well, that's not bad because it is bad in one aspect. This formula is not on the chart, okay? So, and we need surface area, not volume. If it was volume, we could be done very quickly. So, think about it like this, okay? We know that the circle on the bottom is pi r squared, okay? And we need to add that to the lateral surface area, which is pi times the r times that L, okay? And the L, this is going to be our slant height. This is just something, if you're asked, you have to know it. Now, maybe you won't be asked this on the test. Now, I have been asked on a practice test before. If you have to take the university practice test, yes, okay? But you will need to know this when you teach your students. So please be aware. Okay, now, remember my trick. Pull out your pi, let him hang out on the side, okay? Pull him out, and then you need to type in this, okay? Because this is in terms of pi. So let's give it a try. Let's see, they say the radius is 7, okay? So we need 7 squared, and we're going to add it to 7 times the 15 lateral, okay? That, or not lateral, but the slant, okay? So push enter, and that is the first one, A, 154 pi. There you go. Don't forget to put the pi back on the end, okay? And remember, if you accidentally put it in, just divide to get rid of it. All right, let's go to number 4. Number 4, a rectangular pyramid with a square base has sides equal to 9 meters and a volume of 250 cubic meters. What is the perpendicular height of the pyramid? Okay, so we can look this up on our formula sheet, okay? And we're going to get the base squared times height divided by 3. Okay, but we're going to use our table to solve that and use our ask function. Okay, so let's push table, clear out what's there. We need another fraction. Okay, so it's the area of the base, which is, they say each side is, it's square, so it's 9 times 9. So I have 9 squared times the height, which is x. We don't know what the height is. So they want h, the perpendicular height. So we're going to call that x, okay, in the calculator. Now, that would be base times height divided by 3 because a pyramid is a third of the square cube, okay? Because this is a regular square base, okay? Well, it could be longer. Either way, it doesn't matter. Still divide by 3, okay? So we need to know what x is. So this is what we need to do. All right, do what we've been doing. We set it up with 0, 1, and ask. And now we're going to clear everything out because that's from an old situation. Okay, now let's put 6.26 and enter. Oh, but it doesn't give us 250. It gives us some weird fraction. Don't calculate that. Don't back out or get another calculator and calculate it. Don't do it. Arrow over and up, go to it and highlight it. Now, push your toggle. Well, that is not even close to the 250 that we're looking for as our y. Okay, that would be our volume. Okay, remember the formula we entered was for volume. Okay, well, that won't work. That's okay. So let's try it again for B. So you have to go back and over, and let's try 9.26 and enter. Go over, do the same thing I did by using the toggle button. Ooh, that gives us something very close to a volume of 250. So I'm going to circle that, but I'm going to keep going and I'm going to try the other values. So let's try C, 27. I don't think so. Nope, way too large. 729 cubic meters? Don't think so. So let's type over 4.3. Okay, that gave us a weird fraction again. So just arrow over, push your toggle. It is not going to be large enough. That would be a little over 116. So no, that won't work. So that's a good way to do it. Now you know another tip about dealing with fractions, okay? All right, now let's look at number 5. The volume of a sphere is 5 times the surface area of the sphere. What is the value of the radius of the sphere? Okay, I want to have you think about something. Okay, we're talking about volume of the sphere. Now they're saying that the volume equals 5 times the surface area. Okay, now as we've done in other videos, those two things equal each other. So if we subtract them from each other, that would be volume minus volume equals 0. So let's put that in our calculator, and then while we search using these x values, which x's are in our calculator, okay? Right, so this will be x in our calculator, and that's our answers that they're looking for, okay? Probably on an exam, it would say R for radius, but we've got X, that's what we're going to do. So we're just going to look and see in our Y value what equals 0. Okay, so let's type that in. So I'm just going to clear until I go back, clear the whole thing. Now, first, I need volume. You need to look that up on your formula sheet, okay? And the volume of a sphere is 4 pi, and notice nothing is in terms of pi, so we need to type in the pi. We need it. 4 pi, and that's times r to the third, because it's volume, so it'll be to the third power. So we need x carried up to the third. Remember, we're using x instead of r. And then go down, and that all is divided by 3. Now that's our volume. Arrow over and subtract 5 times the surface area. Okay, like I mentioned in another video, that would be the first derivative of the volume we already have typed in, but it's on your formula sheet. So that will be 4 pi r squared. So that's 4 pi x squared for us. Close our parentheses, push enter. Now we have everything set up to use ask. That's what we need. And arrow down, push enter. And I'm going to delete out because I need you to see what I'm doing clearly. Let's try 55 first. 55, enter. That's not 0. 25, enter. Nope, let's try 15. 15, enter, and that is 0. So I'm saying, oh, let's see, you can see, that's what we need. Now let's go up and delete out the first one and go ahead and try 35. Always better safe than sorry. And no, it doesn't work. So C is verified. All right, so now let's go to number 6. Okay. If the height of an isosceles trapezoid is 3 and the area is 12, what is the length of the second base B2? And the drawing is not to scale. So this is what they want, this bottom part right here. Now, the fact that this is isosceles tells us some nice things, okay? Here and here, and I have this, okay? Well, it tells me that I have a square in the center. And you could use that to solve for the length, but I'm not going to do that, okay? I am going to go and use the fact that it is isosceles and that we are looking for, or we can use area, okay? Because it says the area is 12. So this is what we're going to do. The area equals B1, which is 3, plus B2. We're going to call B2 X because that's what we're putting in our calculator. And then the height is given as 3, and that is all divided by 2. And it is equal to 12. 12 is what we're going to look for in the calculator, okay, on our Y value. Okay, that's going to be the Y. All right, so let's clear everything out. Let's get this typed in. Okay, ooh, that's a bunch of stuff. We really need to clear it all out. Start with a new fraction. Parentheses 3 plus the x, close. We have another 3. Now that's just a coincidence. Okay, now arrow down, divide by 2. Now let's use x as b2, remember? So we're going to enter and use that as function again. Okay, here, let me get rid of all this. Go up and let's try it. Let's try 3. No, that's not gonna work because we're looking for 12. Right, let me mark it out. Oh, again. Okay, let's try 9. No, that's too large. Okay, let's try 7. Oh, still too large. Okay, I'm thinking 5 might do it, but if it doesn't, we'll figure out why not. All right, so 5, enter. And luckily, yes, it is D, the last one. And that got it for us. It's verified. Okay, this is the last number in this particular video. I wanted to thank you guys for watching, subscribing, liking, and sharing. Thank you for sharing. When you share with someone who finds these videos beneficial, you help us and you help them. Okay? And thanks, everybody, and congratulations to those of you who have recently passed your test. Happy testing, everybody.